welcome to the channel. In front of you here is the spindle of one of my polishing machines. I'll just zoom out so you can see what the thing looks like. So it's a twin spindle machine, so there's a spindle this side, spindle that side, and the work screws onto this thread here, and then the polisher goes on the top, or the lapping plate, and there's a pin here that goes in the back of the tool. I'll put some footage in so that you can visualize what's going on. But this arm moves from side to side and the spindle rotates. And the issue I've got is I have a lapping plate here that I want to screw onto the spindle, but this is not the same thread as what I have in the back of the lapping plate. So I need to identify that thread. I think I know what it is, but I need to identify it. So I'm going to show you how I'm identifying the thread. I'm going to measure the outside diameter and the pitch of the thread, and then I'm going to look it up in the holy writings of Zeus, so I can just double check all the numbers stack up, and then that will confirm that this is the right tap, because I'm going to use that to make an adapter to go onto that thread, and then it will screw into the back of the lapping plate, and it's going to look something like this, but on a bigger scale, just slightly bigger than this. So I'll have a female thread in the back and a male thread on the top. Okay, so let's zoom in and take some measurements. Okay, hopefully that's clear enough to see. So what I'm going to do is I'm going to measure the outside diameter of the threads with the digital caliper, and that's coming out at 0.87 inches, and I'm measuring in imperial because it's very likely that this machine is imperial because it's based on a very old design. Well, I'll say very old, yeah, mid 20th century design, I would say. Okay, so 0.87, and then the other thing I've done is I've got a thread gauge here, and I've already selected the thread gauge because I've already checked this off camera. So what I'm going to do now is just bring the gauge in. Hopefully you can see that well enough. I'm going to zoom in and hopefully it will be visible. So that is a 9 TPI thread gauge. So with those two pieces of information, we'll turn to the Zeus bug, and I'm going to go to the UNC table, which is this one. Let me move the camera up a little bit, 1 second. Yeah, so we're on the UNC page. So UNC is Unified Course. And we had a measurement of 0.87 inches. So I'm looking on the outside diameter column. So down to 0.875 is that number there, and then alongside it, it does confirm that it's a 7/8 of an inch by 9, and the 9 signifies the number of threads per inch. So that coincides with this tap that I've got. So I bought this in advance of doing the video and before today. So this is a 7/8 by 9 UNC tap. It's a second tap. I didn't buy a first and a plug tap because I'm too stingy. So I've decided that what I'm going to do is when I make the adapter, I'm going to make it long enough so that the taper section of the tap is well away from the end of the thread, so that I can make sure that I've got good enough thread engagement. So I'm going to go and put some material in the lathe now, and we'll get cracking on that. So I'm over at the polishing machine now, and I've had to go to plan B here. So the part that I was making on the lathe, you saw me drill and tap it 7/8, and I turned the part around in the machine because I was going to turn the spigot on ready to machine an M20 male thread on here. So I was going to single point turn the threads because I don't have an M20 die. Now, like an idiot, I came in to put the undercut in so that I could clear the end of the thread, or the end of the threading tool, and lo and behold, I didn't make the part long enough, and I just parted straight through with the parting tool, straight into the hole that was behind it. It should have been another 5mm longer, or 5 or 10mm longer. What an idiot. But what can you do? You just can't get the staff. So what I did was, because the hole wasn't threaded all the way through, it was just drilled, I stuck an M20 tap down it, so that what I'm able to do now is, with a cut down M20 bolt, I can turn a few threads into there like that, and I've ended up with an approximation of what I would have had before. It's not the best, but I don't want to make this again. Because I've got a reduced engagement now on the 7/8 thread, off camera I just made, from an offcut, I just made this little brass spacer, so that will go over the threads on the spindle of the polishing machine. And then let's get the right end here, so the 7/8 thread goes onto there, so that's a nice fit on there. And then what I'm able to do with this is I can wind in the M20 stud, so that's there now. And then with the lapping plate here, which is what I wanted to fit onto here, that should fit nicely onto there. Does it fit? It should do, because it's an M20 bolt. Yeah, that's screwing on. Okay, so that's nice and firm on there. So I'll turn the polishing machine on and we'll just give it a test rip. Yeah, so that's fine. Okay, so I'll be able to use this machine now. Great. Well, a couple of plot twists in this one. As usual, it's easier to produce a drawing in the long run sometimes. So yeah, this machine now is ready to go, and this is what it looks like. Right, well there we go. It's just a quick video, this one, and thanks for joining me, and I'll see you on the next one. Bye for now.